Algebra 2 students. Today we start with our first screencast of the year. The title is Relations and Functions. The first thing is, what is a relation? Now, a relation is simply just a relationship between two numbers. It's or we can call it a collection of ordered pairs, x comma y. You can also think of it sometimes as an equation relating an independent variable x and a dependent variable y. Okay? Now, each of these numbers in the relation, the x's and the y's, has a name. The domain is all the x's. The range is all the y's. And the range is the set of all output values called the y's in the relation or function. Okay, so let's take a look at what I'm talking about. I've got three ways to represent a relation. I can list a relation as a set of just point or ordered pairs like this, 5, 2, negative 3, 4, and 6, 7, 5, negative 8, right? This set of points is a relation, okay? If I want to know what the domain is of this function, of this relation, I say, well, my domain is a set of all x values. So my domain here would be, well, 5, negative 3, 6, and, well, wait a minute, 5 was already in the list, so do I need to list it twice? Nah, we can be lazy and not write it out twice, right?
I think we're right.
My range, okay, the range of this would just be your y values. So my y values in this are 2, 4, 7, and negative 8. Now, in both of these, I'm kind of a bad boy because I really should list these in order from smallest to largest. So my domain, I'm going to write it as negative 3, 5, and 6. And my range, I'm going to list it as negative 8, 2, 4, and 7. And that's my domain and range of that relation. Okay? All right, now let's take a look at another example where I have a graph. So I can have these, instead of listing these values out as ordered pairs, I can list them out as points. So I can have like a point here, I can have a point here, 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 and here. Okay? That's another way of writing a relation, right? And the last way to represent a relation is just represent it with a function right here, as you can see. Okay? So there are the three ways of writing a relation: as a set of ordered pairs, as a bunch of points, and as an equation. Now the next idea, what is a relation, what we call a function? All right? Well, a function is where you have a relation where none of the x's repeat. All right? Another way of looking at it, it's where you have a rule or an equation in which for every value of your input, for the independent variable, you get a single value as an output. Okay? So let's take a look at some examples. Let's determine whether each relation represents a function or not. Again, we're only focusing on the x values. Do the x's repeat? Well, again, we said that we could represent a relation as a set of ordered pairs, right? So if you take a look at this, do any of my x's repeat? Well, let's see. My x values are 6, negative 24, and 3.5. Therefore, since none of them repeat, it's a function. Notice I don't care about the y values. Now, what's my domain for this guy? Well, my domain in this will be negative 24, 3.5, and 6. My range would be 0 and 6. Okay? Let's take a look at another example. Again, let's look at some points, right? In this case, let's see. So let's decide, I'm going to go ahead and make an xy table just to see if my x's repeat. Let's see the first point right here, this guy right here. His point is negative 3, negative 2. The second point would be 1, negative 2. And the next one, I've got 2 points above each other, so 4, 1 and 4, negative 5. Okay? As you can see, the x's line up right on top of each other, right? Well, one short way of figuring out if a graph represents a function or not is to use something called the vertical line test. The vertical line test basically says if you imagine a vertical line going across a graph, right? Does this vertical line ever touch the graph at more than one point at the same time? Well, if you look right here, would you agree that this vertical line is touching those 2 points at the same time? So that's what makes it not a function. So again, as you drag a vertical line across, if you imagine a vertical line dragging across this graph, if you see it touch the graph at 2 points at the same time, then it's not a function. Okay? All right. Now, what's the domain of this? Well, I already kind of listed out the domain, haven't I? In my xy table, my domain would just be -3, 1, and 4. And my range would be -2, 1, and -5. Okay? Again, I didn't put them in order, and I should have. Okay? All right. Let's take a look at the next idea. Look at this graph. All right? Now, this graph is kind of a funky little circle. All right? Well, again, if I imagine dragging a vertical line across this graph, right? Would it ever touch the graph more than one point at the same time? Well, sure. All throughout, right here and here, it's touching it at more than 1 point. So, as you can see, this doesn't pass the vertical line test. This is not a function. All right? Now, let's see the domain of the range. Now, if you notice, this graph is different from the graphs above in the fact that the graph is continuous. It's not just a list of independent points. Well, if I have independent points, my domain and range are independent values. They're single x and y values. But if it's continuous like this, I can't just list out individual values because the graph is continuous. So that means that this right here, actually this point right here, has an x value that's some decimal. It could be like, say, 1.41, comma, 0.23, right? All right, so it would be impossible to actually list out the individual x values. So what I can do is I have to list out my domain and my range as inequalities. All right? So in this case, I'm going to look at my domain. Now remember, domain is how far to the left does this graph go and how far to the right. Well, if I look all the way to the left, this graph ends right here on the x-axis at 1. It ends on the right at 5. Now again, the domain is about the letter x, so I say that my x's have to be greater than 1, but less than 5. Now does it look like they're actually touching 1 and 5? Looks like it to me, so instead of just being less than, it'll be less than or equal to, and less than or equal to here, right? In English, we read this as x is between 1 and 5. Now my range talks about the y values of the graph. So if I'm looking at my y values, what's the lowest y value that this goes down to? I look down to here. What's the highest it goes up to? Here. So I say my range would be y is between -3 and 1. And it's actually looking like it's touching those values, so we'll include -3 and 1. Does that make sense? Hope so. All right, and then last, let's go one more time. Look at this graph. Again, if I drag the vertical line across this graph, would it ever touch the graph at more than 1 point at the same time? Let's see here. 1 point, 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 1 point. So as you can see, it's constantly touching this graph at only 1 point at a time, so this is a function. Now again, if you think about it, my domain is continuous. It's touching a whole bunch of x values as I go across. It never has any gaps in it, right? So again, anytime you see a continuous curve, I can't list out these domains as individual values. I can only give an inequality of values, right? Now the reality is, though, this graph, even though it's going to the left, even though it's going up on the left and up on the right, it actually keeps on extending outward to the left and to the right forever. So I'm going to say that my domain on this graph, because it keeps on going to the left and to the right forever, is all real numbers. Okay? Now the range. The range of this guy is how far down to how far up it goes. Now again, the lowest that this graph goes down to do, I'd say it would be to write it to this point right here. Now, what is this y value? Oh gosh, I'm going to have to estimate that. It looks like, I'm going to say it's about negative 1.6. So let's see here. How do my y values compare to this 1.6? Well, it looks like all my y values are greater than or equal to that 1.6. Now, does this have an upper value? Does it ever stop going up? No, right? These arrows tell me it keeps going up forever. So my range would just be all y's greater than or equal to negative 1.6. All right? And that's the domain and the range of this function. Okay? The last idea. The last idea of the day is function notation. Function notation is just another way of writing an equation. Instead of the letter y, we use the phrase f of x, or the function of x. So I can rewrite this y equals 3x squared minus 4 as just f of